All right, picture this. A rogue drone suddenly appears over a packed stadium. How do you stop it? But maybe more importantly, how do you even find it in the first place without spying on every single person down below? Well, today, we're diving into the incredible tech that has to walk that super fine line between security and our privacy.
This isn't just some tech puzzle. This is the central question that governments and security experts are wrestling with right now. Because if you get it wrong, you either fail to stop a very real threat, or you accidentally build a massive surveillance system that tramples all over our fundamental rights. The stakes? They literally couldn't be higher.
To try and get this balance right, a joint interagency task force just put out brand new guidelines on March 9, 2026. This document, it's the whole shebang. It lays out the entire operational and legal framework for what they call counter-unmanned aircraft systems, or CUAS for short. At the very heart of these guidelines is this fundamental conflict, right? On one hand, we obviously need to protect our public spaces. Think airports, stadiums, critical infrastructure from potential drone threats. But on the other hand, we have to fiercely protect our right to privacy and the confidentiality of all our communications.
The entire legal framework really hangs on this one critical distinction. Think of it this way. Legal signal analysis is like looking at the outside of an envelope. You can see the address, the stamp, maybe its size and weight, and you can learn things from that. Illegal communication interception, that's like steaming open the envelope and reading the private letter inside. One is a security survey, the other is straight up eavesdropping.
So how do they do this legal signal analysis? Well, the technique is called signal fingerprinting. Instead of even trying to read the data, the system analyzes the unique physical shape of the radio wave itself, its frequency, its power, its timing. This creates a unique signature, kind of like a fingerprint, that can identify a device as, say, a specific model of drone, and not your phone's Wi-Fi or your headphone's Bluetooth signal. And this quote right here, it gets to the absolute guiding principle of these new guidelines. These systems are intentionally built from the ground up to be security tools, not spying tools. The entire design philosophy is built around one goal: identify the threat while actively, and I mean actively, avoiding any private communications. And to make sure they stay on the right side of the law, these CUAS systems follow some extremely strict data minimization rules. The raw signal gets processed in real time, and poof, it's immediately gone forever. If the system accidentally picks up even a tiny piece of the actual data payload, the letter inside our envelope, it's instantly filtered out and discarded. That content is never, ever read, decoded, or stored. Okay, let's get into the fun stuff. The technology that actually makes all of this possible. And I'll tell you right now, it's not just one magic box. It's a really sophisticated, layered system. It's so important to understand this. There is no single silver bullet for detecting drones. Instead, a really effective system relies on a whole suite of different sensors. Each one has its own unique strengths, and they all work together to build a complete picture of the airspace. So, here's how these layers actually work together. First up, radar gets a ping. It detects a physical object and starts tracking its speed and direction. Instantly, the RF detection system scans for radio signals coming from that object. Using that signal fingerprinting we just talked about, it confirms, yep, that's a drone, and can even start to triangulate where the controller is. At the same time, acoustic sensors might pick up the unique whine of the drone's propellers. With the threat confirmed, high-powered cameras, we're talking electro-optical and infrared, are cued to get actual eyes on the target for the final visual confirmation. And that is the key to the whole system. This layered approach means each technology covers for the potential blind spots of the others. What you end up with is this really robust detection net that is incredibly difficult for an unauthorized drone to sneak through. So we've got the technology. It's cool, it's layered. But what about the legal guardrails that govern how it's used? This is where the rules get incredibly specific, as you might imagine. Okay, there are three major federal frameworks you gotta know. First, there's the Electronic Communications Privacy Act, or ECPA. The bottom line there is super simple. You cannot intercept the content of a communication, period. Second, you have the Pen/Trap statute. This protects the non-content info, the metadata, like who is talking to whom. And finally, all this gear has to be authorized by the FCC to make sure it's not illegally messing with the public radio spectrum. So we've found the drone, and we've done it legally. But now what? What about stopping it? Well, this is where the rules get even more strict, and they draw a very, very bright line in the sand. On the left side, you've got passive detection. This is simply listening for signals that are already out there in the air. It's everything we've been talking about, and it's generally permitted for private and non-federal groups. Think local police or stadium security. But on the right, you have active mitigation. This means actually doing something to interfere with the drone, like jamming its signal or trying to take it over. This is a huge no-no for everyone except a few very specific authorized federal agencies. And this really brings us to the absolute bottom line for any non-federal group out there. Your authority ends at detection. You can look and you can listen, but you cannot touch.
And the reason for this really hard line, well, it comes right back down to those two powerful federal laws. While laws like the ECPA and the Pen/Trap statute do have some very narrow exceptions for federal agents, the source material is crystal clear on this. Those exceptions are completely unavailable to private companies or local agencies. For them, that legal door is slammed shut.
So all of this leaves us with a critical question for the future. The delicate balance we've just walked through is based on today's radio-controlled drones. But what happens when they start communicating over the cellular LTE network or even fiber optics? As the technology of the threat evolves, will our detection methods and maybe more importantly, our privacy laws be able to keep up?